Enceladus is the sixth largest moon of Saturn. It is approximately 500 kilometers in diameter, about a tenth of that of Saturn's largest moon, Titan. Enceladus is mostly covered by fresh, clean ice, reflecting almost all the sunlight that strikes it, making its surface temperature at noon reach only -198 degrees Celsius. Despite its small size, Enceladus has a wide range of surface features, ranging from old, heavily cratered regions to young, tectonically deformed terrains that formed as recently as 100 million years ago. Enceladus was discovered on August 28, 1789 by William Herschel, but little was known about it until the two Voyager spacecraft passed nearby in the early 1980s. In 2005, the Cassini spacecraft started multiple close flybys of Enceladus, revealing its surface and environment in greater detail. In particular, Cassini discovered water-rich plumes venting from the South Polar region. Cryovolcanoes near the South Pole shoot geyser-like jets of water vapor, other volatiles, and solid material, including sodium chloride crystals and ice particles, into space, totaling approximately 200 kilograms per second. Over 100 geysers have been identified. Some of the water vapor falls back as snow, the rest escapes, and supplies most of the material making up Saturn's E-ring. According to NASA scientists, the plumes are similar in composition to comets. In 2014, NASA reported that Cassini found evidence for a large South Polar subsurface ocean of liquid water with a thickness of around 10 kilometers. These geyser observations, along with the finding of escaping internal heat and very few impact craters in the South Polar region, show that Enceladus is geologically active today. Like many other satellites in the extensive systems of the giant planets, Enceladus is trapped in an orbital resonance. Its resonance with Dione excites its orbital eccentricity, which is damped by tidal forces, tidally heating its interior, and possibly driving the geological activity. History. Discovery. Enceladus was discovered by Frederick William Herschel on August 28, 1789, during the first use of his new 1.2 meters telescope, then the largest in the world. Its faint apparent magnitude and its proximity to the much brighter Saturn and Saturn's rings make Enceladus difficult to observe from Earth with smaller telescopes. Like many satellites of Saturn discovered prior to the space age, Enceladus was first observed during a Saturnian equinox, when Earth is within the ring plane. At such times, the reduction in glare from the rings makes the moons easier to observe. Prior to the Voyager missions, the view of Enceladus improved little from the dot first observed by Herschel. Only its orbital characteristics were known, with estimations of its mass, density, and albedo. Naming Enceladus is named after the giant Enceladus of Greek mythology. The name, like the names of each of the first 7 satellites of Saturn to be discovered, was suggested by William Herschel's son John Herschel in his 1847 publication Results of Astronomical Observations Made at the Cape of Good Hope. He chose these names because Saturn, known in Greek mythology as Cronus, was the leader of the Titans. Features on Enceladus are named by the International Astronomical Union after characters and places from Burton's translation of the Book of 1001 Nights. Impact craters are named after characters, whereas other feature types, such as Fossae, Dorsa, Planitia, and Sulci, are named after places. The IAU has officially named 85 features on Enceladus, most recently Cimmeria Rupes, formerly called Cimmeria Fossa. Orbit and rotation. Enceladus is one of the major inner satellites of Saturn along with Dione, and Mimas. It orbits 238,000 kilometers from Saturn's center and 180,000 kilometers from its cloud tops. Between the orbits of Mimas and Tethys, it orbits Saturn every 32.9 hours, fast enough for its motion to be observed over a single night of observation. Enceladus is currently in a 2-to-1 mean motion orbital resonance with Dione, completing 2 orbits around Saturn for every 1 orbit completed by Dione. This resonance maintains Enceladus's orbital eccentricity, which is known as a forced eccentricity. This non-zero eccentricity results in tidal deformation of Enceladus. The dissipated heat resulting from this deformation is the main heating source for Enceladus's geologic activity. Enceladus orbits within the densest part of Saturn's E-ring, the outermost of its major rings, and is the main source of the ring's material composition. Like most of Saturn's larger satellites, Enceladus rotates synchronously with its orbital period, keeping one face pointed towards Saturn. Unlike Earth's moon, Enceladus does not appear to librate about its spin axis. However, analysis of the shape of Enceladus suggests that at some point it was in a 1 to 4 force secondary spin orbit libration. This libration could have provided Enceladus with an additional heat source. Source of the E-ring. Plumes from Enceladus, which are similar in composition to comets, have been shown to be the source of the material in Saturn's E-ring. The E-ring is the widest and outermost ring of Saturn. It is an extremely wide but diffuse disk of microscopic icy or dusty material distributed between the orbits of Mimas and Titan. Mathematical models show that the E-ring is unstable, with a lifespan between 10,000 and 1 million years. Therefore, particles composing it must be constantly replenished. Enceladus is orbiting inside the ring, at its narrowest but highest density point, raising suspicion since the 1980s that Enceladus is the main source of particles for the ring. This hypothesis was confirmed by Cassini's first 2 close flybys in 2005.